In this session, we will set up and run WaveDevice on a Golden AP card, an RFA 36014 for the first time. We have the Golden AP WaveDevice application open now. The first thing we'll do is connect to our system. So in similar fashion to other applications, we tend to work our way down the left-hand side of the screen. So we'll start with System, where we're going to connect to a chassis that we know we have a card in. I've typed in WT-TGA0031. There are two cards in that chassis that I could be using. I'll select one and reserve it. Now you can configure the radio on that card to whatever channel you like. We've chosen channel 36. So now the port is selected and the channel for the port that will be making up our access point is selected. Next, we click on Access Point Characteristics. Here you can set the SSID, you can set the BSSID, you can choose security type, what type of access point. In this case, we'll let it be an 802.11ac access point. The device we're talking to is a single spatial stream 802.11ac product. Set channel width, channel model, default transmit power, country code, indoor or outdoor environment. These will set up information elements in the beacons, beacon interval. You can set the supported rates, legacy supported rates that will be advertised. Finally, we're down here, since we've chosen an 802.11ac style access point, we can now choose the VHT rates that will be offered. In this case, we'll make it one spatial stream, since the device that we're testing is one spatial stream, and we'll support 0 through 9. Notice if we were to have chosen this access point to be an 802.11n, this would have changed to HT rates to give us the ability to choose what HT rates we're going to test for. So we can make this access point, this golden access point, offer up whatever services we so desire. All right, so we'll choose 802.11ac, one spatial stream, MCS 0 through 9, short guard interval. So that in the beacon, we will be describing that's the capabilities that the access point will support. We can set up whether we support AMPDUs or not, and set up QoS capabilities, right? So this gives you a totally programmable access point where you can enable and disable things and change the personality that you want to present to your client. This is a very powerful part of this tool. Trying to do all of these things on a commercial access point is impossible. Many of these features and selections aren't even offered. But here you have the ability to set things up the way that you want. Then once we have determined and set all of the characteristics of the access point, we activate the access point. Now that card is acting as an access point, and it is sending out the beacons to announce its presence to any nearby client. Well, it turns out that we have a client who's already looking for the Golden AP SSID. So when we go to devices, that device shows up here. Now remember, these are devices that must be running Wave Agent. So prior to this moment, I've already programmed that client to look for that SSID, and I've started Wave Agent. So now this green means that the device named Windows Phone 8 has gotten an IP address from our golden access point, and the application has been able to ping all the way through to the agent and get a reply from the agent to know that the pathway to send and receive traffic all the way from our traffic generator analyzer in the Golden AP card itself can talk all the way through to the Wave Agent in the device under test. Now we can choose what type of test we want to run. We can run a simple test, which is either downstream, upstream, or bidirectional traffic of either UDP or TCP. We set our transmit power. This is a TX power of our card. The phi rate we wish to use, we can set it to a specific phi rate when we transmit, or we can let the application choose that for us. But again, make sure that you remember that the card will only rate adapt if there is an option that has been added to rate adapt. So this is something you should check for. It does not automatically rate adapt. That's a valuable choice of this access point, because when you're testing a client, you would like to know exactly what is being subjected to the client. In this case, we are setting the phi rate and not adapting around. So if there are receiver problems with the device under test, you'd like to be able to know that and trust that the access point as it's transmitting is doing something predictable. Here we're going to set up the traffic properties, frame size, and data rate. In this case, we'll do downstream. Downstream means the access point product, our card, is going to be transmitting, and the device under test, the client device, is going to be receiving. If we do upstream, it's just the opposite direction of that. So let's try an upstream test first. When we have finished setting these up, we can hit start. Now over on the right hand side, I want to draw your attention to the data that we are now capturing. The unique part of this application is we are seeing data about the flow, data about the client, and data about the port. And let's look at each one of these individually. The transmit frame rate out of the device is what the wave agent is reporting back as being how many frames per second it's generating. The receive frame rate is how many frames per second the blade card is receiving. Any of these that have a little icon next to it of a graph will allow us to look at a chart over time. And we can, by pointing and rolling the mouse button, we can zoom wherever we want to. So notice here, I can zoom vertically if I put the pointer on the left-hand side. If I put it in the bottom, I'll zoom horizontally. So this is a ongoing graph of the smooth inter-arrival jitter. Remembering we're upstream, the client is doing all of the transmitting. So if we were wondering what was going on with AMPDUs, we can see that, well, at this rate, all AMPDUs are 1 MPDU long. 10 megabytes, that's not really a surprise. But at a glance, we can see characteristics of what's going on without actually doing a packet capture. Well, we can do a packet capture, and we'll show you that in just a moment. Here's the phi rate that's being used, so we can see that the product is transmitting a constant 390 megabit phi rate. That's MCS 8, 80 megahertz bandwidth. There you can see it's been constantly transmitting MCS 8. So without even doing a packet capture, we can take a look at what the performance of the client device is directly. Now let's look here. There's media utilization. There's also failed ACK frame rate and FCS errors. So we can tell just by looking at these statistics what's going on over the air interface and the relationship between the wave agent and our traffic generator analyzer. We can see here that we are not receiving any errored frames. The frame error rate is 0. That's very encouraging, and we're seeing 10 megabits of traffic. So let's stop the test and go to 100 megabits of traffic and see what happens. So now we see we're asking for 100 megabits of traffic. The amount of data that we're getting is more around the 50 megabits worth of traffic. And we're seeing that we have now an FCS error rate that has popped up, right? So this tool gives us the ability to connect up to a client device, present it with an access point, and then we can choose the type of test we want to run and gather the statistics directly off of the screen. There are simple tests which just run continuously. There's a general data plane test. This gives us the ability to set up a sequence of test runs. Here, the general data plane test, you can choose traffic types, upstream or downstream directions, frame lengths, and percent of theoretical. Now you can go through and edit these choices. So if you wanted to run a very exhaustive test of a variety of different frame lengths, you can set it up as incrementing. and you can choose whatever load you want. Here, if we edit it, we can use percent of theoretical, or we can use megabits per second or packets per second to set the intended load. What this test does is gives you the ability to run a sequence of tests, and then it gives you the ability to then produce a printed result of that. Now, once you've gone beyond simple tests, you have the choice to do a series of tests. You also have trial duration, settle time, and aging time choices. You also have a rate versus range test, which will test the receiver. This is a very important test. Gives you the ability to choose a variety of different phi rates and transmit powers and your I load. And now you can basically draw the receiver sensitivity curves for any client device. You have a set of fixed parameters, which are primarily the frame size, and then other options, which is how long you want the thing to run. This is the most effective way to test the receiver of a finished product that's on the market today. And again, you can choose a variety of different phi rates. You can choose only a certain number of phi rates if that is your preference. So this tool gives you the ability to create your own access point and run a simple or very specific set of tests on the device, as long as you can mount a wave agent on it, while you can view many statistics at the flow, client, and port level. A couple of other things we'll add in here. This is monitoring on the right-hand side. You can choose other things to monitor by selecting from the checkboxes that are shown here. So you have a great number of statistics that you can add to this monitoring down the right-hand side here. If your main concern is around management frames and how the client is connecting up, you can look at those details. If your concern is more towards the forwarding rate and performance at high speed, you want to set up things to look for client behavior and port behavior. Also, in the middle of running a test, you can do a packet capture. So you can clear and download and view the capture and see the Wireshark representation of what's going on directly out of the client at the air interface. Let's do that. So we're running upstream traffic. Let's go back to our 10 megabits in order to keep it rather small. So now we see we're running 10 megabits of traffic. If I go here and clear the capture, then download and view the capture, while I've set up a very controlled situation here, now I can go in and get a packet capture, and I can see exactly what the blade card is seeing at the interface. Here are packets coming from the client under test, and here are the acknowledgments going back. So we can do analysis at the air interface either by packet captures or by looking at the statistics. So if somebody's looking for a throughput number or a forwarding rate number, and the number is not what they expected, and begin to ask the question of, well, why isn't the number bigger? You can first look here at the statistics to see, do you have problems at the air interface? Are the phi rates as expected? Is the amount of aggregation as expected? And then if you need to go and look at details of what's actually going on during the transmission, you can do the packet captures and pull them open. That's the starting steps of getting your traffic running with a client device using WaveDevice.